Hi there. I apologize for the weird lighting and the poor audio. My phone is not the greatest, and I couldn't complete this at school. Um, Real quick, I'll try to get through this super fast. The homework said that one of the problems is going to be like number four, which we already did in class, and also like a math problem we made up in class, which I just decided was going to be about Delaney's water bottle. So here's how those two work, because the homework problem is exactly like these. First thing, kids have to write down the facts that go with this. In fifth grade, sixth grade, they'll probably be able to simply highlight or find facts. But because we're focusing on reading comprehension and isolating the things that are important, we're writing them down as notes. Kids have to do this step. The first thing that I noticed is that it said Kamala had 5,026 grams of flour in a canister. I didn't write down the whole thing, but I wrote down canister, 5,026 grams of flour. Then it says she bought a 4,157 gram bag of flour. So I wrote down the bag, 4,157 grams flour. It says she poured some flour from the bag to the canister. And then it said, as a result, the mass of the flour in the canister is now twice the mass of the flour left in the bag. This is probably the key to doing the whole problem. And what I wrote down was that the canister is twice the bag. Just a reminder of that fact. I didn't write the whole sentence. Finally, I wrote the question. It says, how much flour is in the bag? I said, question mark, flour in the bag. Now, here's how that bar models paper goes with this. We have a comparison. We've got the, what was it? The bag of flour and the canister of flour. Two things. And what we also heard was that one is a certain number of times bigger than the other. In our example from the original bar model video, we said three times bigger than the other. In this one, it said it's twice as big. So we wrote down that there's a canister, we wrote down that there's a bag, and then we wrote down that the canister has two sections and the bag has one because it's twice as big. Now, the problem is, I don't know how much is in the canister because it says specifically some was poured out. I don't know how much was poured out of the bag, even though it was originally this much. I don't know how much was put into the canister, although I know it was originally this much. What I do know is none of the flour went away. So what I can do is I can get a total for my bar model by putting together the original amounts. So I put together the amount from the canister and the amount from the bag, and I get 9,183. Once I've got that, I can say, hey, the canister kind of gets two sections, and the bag gets one section. That means this 9,183 grams of flour total can be shared between those three sections. And if I divide by 3, I can find out how much there is. So 9 divided by 3, get that 3, subtract, get a 0, and bring down the 1. 3 doesn't fit into 1, so I put a 0. And now a lot of the kids are going to go 0 times 3 is 0, subtract, and get a 1. But you could also just immediately bring the 8 down over here, which I know a lot of us are going to do. 3 fits into the 18 6 times. 6 times 3 is 18. And wow, I'm going to run out of space. With 0 left, bring down that last 3. 3 fits into that 3 only one time. And, oh gosh, I'm not going to bother with that. There's so little space left. So it's 3,061 grams. And remember, I was dividing it by 3. So that means each of these three little sections gets 3,061 grams. 3,061 grams. 3,061 grams. Once I've done that, now I can answer my question of how much flour is in the bag. The bag only has one section. That section has 3,061 grams. So I can answer the bag now has 361 grams of flour. Couple of things that the kids are expected to do. They need this grams of flour to tell me what the number is counting, and they need these extra words to tell me the answer to the question. They don't have to write it in sentence form. They could just stick it right on here. Say 3,061 grams flour in the bag. And if they just did that, I'd be satisfied. That's the basics. You take this little phrase that says a comparison, this is twice as big as that, make your little picture. Even though you don't know how much is in there, you can say, well, there is a total I can figure out by using the original amounts. Take that and split it up, and then you can find out what goes in each thing. Now, the second problem we did in class was this one about Delaney's water bottle. Just word of warning, I don't know that these numbers are exactly the same as what we used in class. I was kind of going off of memory. But we just said Delaney had a water bottle with 538 milliliters of water. Then I had to come up with something new for her to do. So she poured some of it into a Camelback. We had a brief conversation about what Camelback packs are with a little drinking spout. That Camelback started with 652 mils of water in it. I said now the Camelback has 4 times as much water as the bottle. How much water is in each container now? So our facts that we take note of, there are 538 mils in the bottle at first. There's 652 mils in the Camelback at first. And here's the important one that's going to help us draw our picture. After pouring, the Camelback is 4 times as much as the water. Now, do we have to draw a picture for this? Probably not. We could sit here and try and use guess and check. We could try and say, okay, I'm going to make the bottle have a lesser number and the Camelback have a bigger number. I know what they're supposed to add up to, and keep trying and trying until we get something that is 4 times bigger. Bye, baby. You gotta go to the other room. No, baby, you need to go. All right. Then, what we're going to do is take this phrase right here. The Camelback has 1, 2, 3, 4 times as much as the bottle. So, we've got the Camelback and the bottle, just like we had the canister and the bag. Except this time the Camelback is 4 times bigger than the bottle. Now, we know what they both had originally. We don't know what they have now. But we can use those original amounts to figure out a total. So, we'll just put a little bracket here so that we can figure out the total. Add those together. 10, regroup, 9, no regrouping, 11. There's 1,190 mils of water total, no matter how much they started with or how much they have now. Now that I've got this, I can say, hey, I can take that 1,190 and split it up for what I've got in here. And if I split this up, I'm first going to say splitting up means division, so I know I'm going to be doing this. And second, I know that there's 1, 2, 3, 4, 5 sections to split it into, because that's how that comparison bar model works. I can take a total and split it into however many sections total I have. I know it said 4 times more, but there's 5 boxes, so I need to divide by 5. Quickly, we get 2, 10, 1, 9, 3, 15, 4, 0, 8. I know that was rushed, I apologize. So that means there's 238 in every single one of these boxes. And if we know there's 238 in every box, we can answer these 2 questions now. How much is in the bottle now? There's 238 milliliters of water in the bottle. The Camelback is a little bit more complicated. I know how much is in each box, but I've still got to put them all together in order to find the total for the Camelback. So I'm going to take 238, multiply it by 4, or if the kid really wants to, they can do 238 plus 238 plus 238 plus 238. I wouldn't. They can. 8 times 4 is 32. 12 plus 3 is 15. 4 plus 2 plus 1 is... 4 plus 2, my goodness. 4 times 2 plus 1 is 9. There's 952 milliliters of water in the Camelback. Oh, and it's going off the edge of the can. So that's how that works. The problem that they're doing for homework tonight is exactly the same as this. They need to use that phrase that tells them how many times bigger it is in order to make their little picture. They're going to figure out a total, and they probably need the original amounts in order to figure out that total. Once they know the total, they should be able to split it up into their boxes to figure out how much each of the two categories have. So, you'll know how many stickers go in Sophia's binder and how many stickers go in Sophia's locker by figuring out how many spaces each of those things get. Those of you who are algebra minded probably notice this is basically a substitute for algebra. It absolutely is. But you know what? Algebra just isn't developmentally appropriate for fourth graders. Therefore, we do some complicated math problems and we use little pictures that help us get to the answers. That's it. Hopefully, that helps you out with the homework.